A CPU cluster of this performance would cost about $1 million today. DGX Station is $149,000. The ideal AI programming companion for every AI researcher. Today, we're also announcing a new DGX SuperPod, 3 major upgrades. The new 80 gig A100, which brings the SuperPod to 90 terabytes of HBM2 memory, with aggregate bandwidth of 2.2 exabytes per second. It would take 11,000 CPU servers to achieve this bandwidth. About a 250 rack data center, 15 times bigger than the SuperPod. Second, SuperPod has been upgraded with NVIDIA BlueField 2. SuperPod is now the world's first cloud-native supercomputer, multi-tenant shareable, with full isolation and bare metal performance. And third, we're offering Base Command, the DGX management and orchestration tool used within NVIDIA. We use Base Command to support thousands of engineers, over 200 teams, consuming 1 million plus GPU hours a week. DGX SuperPod starts at $7 million and scales to $60 million for a full system. Let me highlight 3 great uses of DGX. Transformers have led to dramatic breakthroughs in natural language processing. Like RNN and LSTM, transformers are designed to inference on sequential data. However, transformers, more than meets the eyes, are not trained sequentially, but use a mechanism called attention, such that transformers can be trained in parallel. This breakthrough reduced training time, which more importantly enabled the training of huge models with a correspondingly enormous amount of data. Unsupervised learning can now achieve excellent results, but the models are huge. Google's transformer was 65 million parameters. OpenAI's GPT-3 is 175 billion parameters. That's 3,000 times larger in just 3 years. The applications for GPT-3 are really incredible. Generate document summaries, email phrase completion. GPT-3 can even generate JavaScript and HTML from plain English, essentially telling an AI to write code based on what you want it to do. Model sizes are growing exponentially, on a pace of doubling every 2.5 months. We expect to see multi-trillion parameter models by next year and 100 trillion plus parameter models by 2023. As a very loose comparison, the human brain has roughly 125 trillion synapses. So these transformer models are getting quite large. Training models of this scale is incredible computer science. Today, we're announcing NVIDIA Megatron for training transformers. Megatron trains giant transformer models. It partitions and distributes the model for optimal multi-GPU and multi-node parallelism. Megatron does fast data loading, micro-batching, scheduling and syncing, kernel fusing, and pushes the limits of every NVIDIA invention: Nickel, NVLink, InfiniBand, Tensor Cores. Even with Megatron, a trillion parameter model will take 3 to 4 months to train on Selene. So lots of DGX SuperPods will be needed around the world. Inferencing giant transformer models is also a great computer science challenge. GPT-3 is so big, with so many floating point operations, that it would take a dual CPU server over a minute to respond to a single 128-word query. And GPT-3 is so large that it doesn't fit in GPU memory, so it will have to be distributed. Multi-GPU, multi-node inference has never been done. Today, we're announcing the Megatron Triton Inference Server. A DGX with Megatron Triton will respond within a second, not a minute, a second, and for 16 queries at the same time. DGX is 1,000 times faster and opens up many new use cases, like call center support, where a 1-minute response is effectively unusable. Naver is Korea's #1 search engine. They installed the DGX SuperPod and are running their AI platform Clova to train language models for Korean. I expect many leading service providers around the world to do the same. Use DGX to develop and operate region-specific, industry-specific language services. NVIDIA Clara Discovery is our suite of acceleration libraries created for computational drug discovery. From imaging to quantum chemistry, to gene variant calling, to using NLP to understand genetics, and using AI to generate new drug compounds. Today, we're announcing 4 new models available in Clara Discovery. Mega Malbart is a model for generating biomolecular compounds. This method has seen recent success within silico medicine, using AI to find a new drug in less than 2 years. NVIDIA ATAC-seq, denoising algorithm for rare and single-cell epigenomics, is helping to understand gene expression for individual cells. AlphaFold 1 is a model that can predict the 3D structure of a protein from the amino acid sequence. Gatortron is the world's largest clinical language model that can read and understand doctors' notes. Gatortron was developed at the University of Florida using Megatron and trained on the DGX SuperPod gifted to his alma mater by Chris Malachowski, who founded NVIDIA with Curtis and me. Oxford Nanopore is the 3rd generation genomic sequencing technology, capable of ultra-high throughput and digitizing biology. 1/5 of the SARS-CoV-2 virus genomes in the global database were generated on Oxford Nanopore. Last year, Oxford Nanopore developed a diagnostic test for COVID-19 called LAMPORE, which is used by NHS. Oxford Nanopore is GPU accelerated throughout. DNA samples pass through nanopores, and the current signal is fed into an AI model, like speech recognition, but trained to recognize genetic code. Another model called Medica reads the code and detects genetic variants. Both models were trained on DGX SuperPod. These new deep learning algorithms achieve 99.9% detection accuracy of single nucleotide variants. This is a gold standard of human sequencing. Pharma is a $1.3 trillion industry where a new drug can take 10+ years and fail 90% of the time. Schrödinger is the leading physics-based and machine learning computational platform for drug discovery and material science. Schrödinger is already a heavy user of NVIDIA GPUs, recently entering into an agreement to use hundreds of millions of NVIDIA GPU hours on the Google Cloud. Some customers can't use the cloud. So today we're announcing a partnership to accelerate Schrödinger's drug discovery workflow with NVIDIA Clara Discovery Libraries and NVIDIA DGX. The world's top 20 pharmas use Schrödinger today. Their researchers are going to see a giant boost in productivity. Recursion is a biotech company using leading-edge computer science to decode biology to industrialize drug discovery. The Recursion operating system is built on NVIDIA DGX SuperPod for generating, analyzing, and gaining insight from massive biological and chemical datasets. They call their SuperPod the BioHive 1. It is the most powerful computer at any pharma today. Using deep learning on DGX, Recursion is classifying cell responses after exposure to small molecule drugs. Quantum computing is a field of physics that studies the use of natural quantum behavior, superposition, entanglement, and interference to build a computer. The computation is performed using quantum circuits that operate on quantum bits called qubits. Qubits can be 0 or 1, like a classical computing bit, but also in superposition, meaning they exist simultaneously in both states. The qubits can be entangled, where the behavior of one can affect or control the behavior of others. Adding and entangling more qubits let quantum computers calculate exponentially more information. There's a large community around the world doing research in quantum computers and algorithms. Well over 50 teams in industry, academia, and national labs are researching the field. We're working with many of them. Quantum computing can solve exponential order complexity problems, like factoring large numbers for cryptography, simulating atoms and molecules for drug discovery, finding shortest path optimizations, like the traveling salesman problem. The limiter in quantum computing is decoherence, falling out of quantum states, caused by the tiniest of background noise, so error correction is essential. It is estimated that to solve meaningful problems, several million physical qubits will be required to sufficiently error correct. The research community is making fast progress, doubling physical qubits each year, so likely achieving the milestone by 2035 to 2040, well within my career horizon. In the meantime, our mission is to help the community research the computer of tomorrow with the fastest computer of today. Today, we're announcing cuQuantum, an acceleration library designed for simulating quantum circuits, for both tensor network solvers and state vector solvers. It is optimized to scale to large GPU memories, multiple GPUs, and multiple DGX nodes. The speedup of cuQuantum on DGX is excellent. Running the cuQuantum benchmark, state vector simulation takes 10 days on a dual CPU server, but only 2 hours on a DGX A100. cuQuantum on DGX can productively simulate tens of qubits. And Caltech, using Contengra QMB, simulated the Sycamore quantum circuit at depth 20 in record time, using cuQuantum on NVIDIA's Selene supercomputer. What would have taken years on CPUs can now run in a few days on cuQuantum and DGX. cuQuantum will accelerate quantum circuit simulators so researchers can design better quantum computers and verify their results, architect hybrid quantum classical systems, and discover more quantum optimal algorithms like Shor's and Grover's. cuQuantum on DGX is going to give the quantum community a huge boost. I'm hoping cuQuantum will do for quantum computing what cuDNN did for deep learning. Modern data centers host diverse applications that require varying system architectures. Enterprise servers are optimized for a balance of strong single-threaded performance and a nominal number of cores. Hyperscale servers, optimized for microservice containers, are designed for a high number of cores, low cost, and great energy efficiency. Storage servers are optimized for a large number of cores and high I/O throughput. Deep learning training servers are built like supercomputers, with the largest number of fast CPU cores, the fastest memory, the fastest I/O, and high-speed links to connect to GPUs. Deep learning inference servers are optimized for energy efficiency and best ability to process a large number of models concurrently. The genius of the x86 server architecture is the ability to do a good job using varying configurations of CPU, memory, PCI Express, and peripherals to serve all of these applications. Yet, processing large amounts of data remains a challenge for computer systems today. This is particularly true for AI models like transformers and recommender systems. Let me illustrate the bottleneck with half of a DGX. Each Ampere GPU is connected to 80 gigabytes of superfast memory running at 2 terabytes per second. Together, the 4 Amperes process 320 gigabytes at 8 terabytes per second. Contrast that with CPU memory, which is 1 terabyte large, but only 0.2 terabytes per second. The CPU memory is 3 times larger, but 40 times slower than the GPU. We would love to utilize the full 1,320 gigabytes of memory in this node to train AI models. So why not something like this? Make faster CPU memories, connect 4 channels to the CPU, a dedicated channel to feed each GPU. Even if a package can be made, PCI Express is now the bottleneck. We can surely use NVLink. NVLink is fast enough, but no x86 CPU has NVLink, not to mention 4 NVLinks. Today, we're announcing our first data center CPU, Project Grace. Named after Grace Hopper, a computer scientist and US Navy Rear Admiral, who in the 50s pioneered computer programming. Grace is ARM-based and purpose-built for accelerated computing applications of large amounts of data such as AI. Grace highlights the beauty of ARM. Their IP model allowed us to create the optimal CPU for this application, which achieves X-factor speedup. The ARM core in Grace is a next-generation off-the-shelf IP for servers. Each CPU will deliver 300 spec-int, with a total of over 2,400 spec-in rate CPU performance for an 8 GPU DGX. For comparison, today's DGX, the highest performance computer in the world, is 450 spec-in rate. 2,400 spec-in rate with Grace versus 450 spec-in rate today. So look at this again. Before, after. Before, after. Amazing increase in system and memory bandwidth. Today, we're introducing a new kind of computer, the basic building block of the modern data center. Here it is. What I'm about to show you brings together the latest GPU-accelerated computing, Mellanox high-performance networking, and something brand new. The final piece of the puzzle. The world's first CPU, designed for terabyte-scale accelerated computing. Her secret codename, Grace. This powerful ARM-based CPU gives us the third foundational technology for computing and the ability to re-architect every aspect of the data center for AI. We're thrilled to announce the Swiss National Supercomputing Center will build a supercomputer powered by Grace and our next generation GPU. The new supercomputer, called ALPS, will be 20 exaflops for AI, 10 times faster than the world's fastest supercomputer today. ALPS will be used to do whole Earth scale weather and climate simulation, quantum chemistry, and quantum physics for the Large Hadron Collider. ALPS will be built by HP Enterprise and come online in 2023. We're thrilled by the enthusiasm of the supercomputing community, welcoming us to make ARM a top-notch scientific computing platform. Our data center roadmap is now a rhythm consisting of 3 chips: CPU, GPU, and DPU. Each chip architecture has a 2-year rhythm, with likely a kicker in between. 1 year will focus on x86 platforms. 1 year will focus on ARM platforms. Every year, we'll see new exciting products from us. The NVIDIA architecture and platforms will support x86 and ARM, whatever customers and markets prefer. 3 chips, yearly leaps, 1 architecture. ARM is the most popular CPU in the world, for good reason. It's super energy efficient. Its open licensing model inspires a world of innovators to create products around it. ARM is used broadly in mobile and embedded today. For other markets like the cloud, enterprise, and edge data centers, supercomputing and PCs, ARM is just starting and has great growth opportunities. Each market has different applications and has unique systems, software, peripherals, and ecosystems. For the markets we serve, we can accelerate ARM's adoption. Let's start with the big one, cloud. One of the earliest designers of ARM CPUs for data center is AWS. Its Graviton CPUs are extremely impressive. Today, we're announcing NVIDIA and AWS are partnering to bring Graviton 2 and NVIDIA GPUs together. This partnership brings ARM into the most demanding cloud workloads, AI and cloud gaming. Mobile gaming is growing fast and is the primary form of gaming in some markets. With AWS-designed Graviton 2, users can stream ARM-based applications and Android games straight from AWS. It's expected later this year. We're announcing a partnership with Ampere Computing to create a scientific and cloud computing SDK and reference system. Ampere Computing's Ultra CPU is excellent. 80 cores, 285 SPECint17, right up there with the highest performance x86. We're seeing excellent reception at supercomputing centers around the world and at Android cloud gaming services. We're also announcing a partnership with Marvell to create an edge and enterprise computing SDK and reference system. Marvell Octeon excels at I/O, storage, and 5G processing. This system is ideal for hyperconverged edge servers. We're announcing a partnership with MediaTek to create a reference system and SDK for Chrome OS and Linux PCs. MediaTek is the world's largest SoC maker. Combining NVIDIA GPUs and MediaTek SoCs will make excellent PCs and notebooks. AI, computers automating intelligence, is the most powerful technology force of our time. We see AI in 4 waves. The first wave was to reinvent computing for this new way of doing software. We're all in and have been driving this for nearly 10 years. The first adopters of AI were the internet companies. They have excellent computer scientists, large computing infrastructure, and ability to collect a lot of training data. We're now at the beginning of the next wave. The next wave is enterprise and industrial edge, where AI can revolutionize the world's largest industries, from manufacturing, logistics, agriculture, healthcare, financial services, and transportation. There are many challenges to overcome, one of which is connectivity, which 5G will solve. And then autonomous systems. Self-driving cars are an excellent example, but everything that moves will eventually be autonomous. The industrial edge in autonomous systems are the most challenging, but also the largest opportunities for AI to make an impact. Trillion-dollar industries can soon apply AI to improve productivity and invent new products, services, and business models. We have to make AI easier to use. Turn AI from computer science to computer products. We're building the new computing platform for this fundamentally new software approach, the computer for the age of AI. AI is not just about an algorithm. Building and operating AI is a fundamental change in every aspect of software. Andre Karpathy rightly called it Software 2.0. Machine learning at the highest level is a continuous learning system that starts with data scientists developing data strategies and engineering predictive features. This data is the digital life experience of a company. Training involves inventing or adapting an AI model that learns to make the desired predictions. Simulation and validation test the AI application for accuracy, generalization, and potential bias. And finally, orchestrating a fleet of computers, whether in your data center or at the edge in the warehouse, farms, or wireless base stations. NVIDIA created the chips, systems, and libraries needed for end-to-end machine learning. For example, technologies like Tensor Core GPUs, NVLink, DGX, cuDNN, Rapids, Nickel, GPU Direct, Doka, and so much more. We call the platform NVIDIA AI. NVIDIA AI libraries accelerate every step, from data processing to fleet orchestration. NVIDIA AI is integrated into all of the industry's popular tools and workflows. NVIDIA AI is in every cloud, used by the world's largest companies and by over 7,500 AI startups around the world. And NVIDIA AI runs on any system that includes NVIDIA GPUs, from PCs and laptops, to workstations, to supercomputers, in any cloud, to our $99 Jetson robot computer. One segment of computing we've not served is enterprise computing. 70% of the world's enterprise run VMware, as we do at NVIDIA. VMware was created to run many applications on one virtualized machine. AI, on the other hand, runs a single job, bare metal, on multiple GPUs and often multiple nodes. All of the NVIDIA optimizations for compute and data transfer are now plumbed through the VMware stack, so AI workloads can be distributed to multiple systems and achieve bare metal performance. The VMware stack is also offloaded and accelerated on NVIDIA Bluefield. NVIDIA AI now runs in its full glory on VMware, which means everything that has been accelerated by NVIDIA AI now runs great on VMware. AI applications can be deployed and orchestrated with Kubernetes running on VMware Tanzu. We call this platform NVIDIA EGX for Enterprise. The enterprise IT ecosystem is thrilled. Finally, the 300,000 VMware enterprise customers can easily build an AI computing infrastructure that seamlessly integrates into their existing environment. In total, over 50 servers from the world's top server makers will be certified for NVIDIA EGX Enterprise. Bluefield 2 offloads and accelerates the VMware stack and does the networking for distributed computing. Enterprise can choose big or small GPUs for heavy compute or heavy graphics workloads like Omniverse, or mix and match. All run NVIDIA AI. Enterprise companies make up the world's largest industries, and they operate at the edge. In hospitals, factories, plants, warehouses, stores, farms, city and roads, far from data centers. The missing link is 5G. Consumer 5G is great, but private 5G is revolutionary. Today, we're announcing the Aerial A100, bringing together 5G and AI into a new type of computing platform designed for the edge. Aerial A100 integrates the Ampere GPU and the Bluefield DPU into one card, This is the most advanced PCI Express card ever created. So it's not a surprise that Aerial A100 in an EGX system will be a complete 5G base station. Aerial A100 delivers up to full 20 gigabits per second and can process up to 9 100 megahertz massive MIMO for 64T, 64R, or 64 transmit and 64 receive antenna arrays. State-of-the-art capabilities. Aerial A100 is software-defined with accelerated features like PHY, virtual network functions, network acceleration, packet pacing, and line rate cryptography. Our partners, Ericsson, Fujitsu, Mavenir, Altran, and Redsys, will build their total 5G solutions on top of the Aerial library. NVIDIA EGX server with Aerial A100 is the first 5G base station that is also a cloud-native, secure AI edge data center. We have brought the power of the cloud to the 5G edge. Aerial also extends the power of 5G into the cloud. Today, we're excited to announce that Google will support NVIDIA Aerial in the GCP cloud. I have an important new platform to tell you about. The rise of microservice-based applications and hybrid cloud has exposed billions of connections in a data center to potential attack. Modern zero-trust security models assume the intruder is already inside, and all container-to-container communications should be inspected, even within a node. This is not possible today. The CPU load of monitoring every piece of traffic is simply too great. Today, we're announcing NVIDIA Morpheus, a data center security platform for real-time, all-packet inspection. Morpheus is built on NVIDIA AI, NVIDIA Bluefield, NetQ network telemetry software, and EGX. We're working to create solutions with industry leaders in data center security: Fortinet, Red Hat, Cloudflare, Splunk, F5, and Area Cybersecurity. And early customers Booz Allen Hamilton, Best Buy, and of course, our own team at NVIDIA. Let me show you how we're using Morpheus at NVIDIA.
It starts with a network. Here we see a representation of a network, where dots are servers and lines, the edges, are packets flowing between those servers. Except in this network, Morpheus is deployed. This enables AI inferencing across your entire network, including east-west traffic. The particular model being used here has been trained to identify sensitive information: AWS credentials, GitHub credentials, private keys, passwords. If observed in the packet, these would appear as red lines, and we don't see any of that. Uh-oh, what happened? An updated configuration was deployed to a critical business app on this server. This update accidentally removed encryption, and now everything that communicates with that app sends and receives sensitive credentials in the clear. This can quickly impact additional servers. This translates to continuing exposure on the network. The AI model in Morpheus is searching through every packet for any of these credentials, continually flagging when it encounters such data. And rather than using pattern matching, this is done with a deep neural network, trained to generalize and identify patterns beyond static rule sets. Notice all of the individual lines. It's easy to see how quickly a human could be overwhelmed by the vast amount of data coming in. Scrolling through the raw data gives a sense of the massive scale and complexity that is involved. With Morpheus, we immediately see the lines that represent leaked sensitive information. By hovering over one of those red lines, we show complete info about the credential, making it easy to triage and remediate. But what happens when this remediation is necessary? Morpheus enables cyber applications to integrate and collect information for automated incident management and action prioritization. Originating servers, destination servers, actual exposed credentials, and even the raw data is available. This speeds recovery and informs which keys were compromised and need to be rotated. With Morpheus, the chaos becomes manageable.
The IT ecosystem has been hungry for an AI computing platform that's enterprise. NVIDIA AI on EGX with Aerial 5G is the foundation of what the IT ecosystem has been waiting for. We are supported by leaders from all across the IT industry, from systems, infrastructure software, storage and security, data analytics, industrial design and automation, to 5G infrastructure. To complete our enterprise offering, software, So business NVIDIA AI Enterprise is optimized and certified support needed by mission-critical enterprises. Deep learning has unquestionably, researchers continue to innovate at light speed with new models and new variants. We're creating new systems to expand AI into new segments like ARM, Enterprise, or 5G Edge. We're also using the systems to do basic research in AI and building new AI products and services. Let me show you some of our work in AI, basic, and applied research. DLSS, Deep Learning Super Sampling. StyleGAN, AI High-Resolution Image Generator. GANcraft, a neural rendering engine turning Minecraft into realistic 3D. Ganverse 3D turns photographs into animatable 3D models. Face Vid to Vid, a talking head rendering engine that can reduce streaming bandwidth by 10x while reposing the head and eyes. Sim to Real, a quadruped trained in Omniverse, and the AI can run in a real robot. Digital twins. SimNet, a physics-informed neural network solver that can simulate large-scale multiphysics. BioMegatron, the largest biomedical language model ever trained. 3D GT, Omniverse synthetic data generation. And OrbNet, a machine learning quantum solver for quantum chemistry. This is just a small sampling of the AI work we're doing at NVIDIA. We're building AIs to use in our products and platforms. We're also packaging up the models to be easily integrated into your applications. These are essentially no-coding, open-source applications that you can modify. Now we're offering NGC pre-trained models that you can plug into these applications or ones you develop. These pre-trained models are production quality, trained by experts, and will continue to benefit from refinement. There are new credentials to tell you about the model application sample code. NVIDIA pre-trained models are state-of-the-art, but there is infinite diversity of application domains, environments, and specializations. No one has all the data. Sometimes it's rare. Sometimes they're trade secrets. So we created technology for you to fine-tune and adapt NVIDIA pre-trained models for your applications. Tau applies transfer learning on your data to fine-tune our models with your data. Tau has an excellent federated learning system to let multiple parties collectively train a shared model while protecting data privacy. NVIDIA federated learning is a big deal. Researchers at different hospitals can collaborate on one AI model while keeping their data separate to protect patient privacy. Tau uses NVIDIA's great TensorRT to optimize the model for the target GPU system. With NVIDIA pre-trained models in Tau, something previously impossible for many can now be done in hours. Fleet Command is a cloud-native platform for securely operating and orchestrating AI across a distributed fleet of computers. It was purpose-built for operating AI at the edge. Fleet Command, running on certified EGX systems, will feature secure boot, attestation, uplink and downlink to a confidential enclave. From any cloud or on-prem, you can monitor the health of your fleet. Let's take a look at how one customer is using NGC pre-trained models and Tau to fine-tune models and run in our Metropolis Smart City application, orchestrated by Fleet Command.
No two industrial environments are the same, and conditions routinely change. Adapting, managing, and operationalizing AI-enabled applications at the edge for unique, specific sites can be incredibly challenging, requiring a lot of data and time for model training. Here, we're building applications for a factory with multiple problems to solve. Understanding how a factory floor space is used over time, ensuring worker safety with constantly evolving machinery and risk factors, inspecting products on the factory line where operations change routinely. We start with a Metropolis application running 3 pre-trained models from NGC. We're up and running in minutes, but since the environment is visually quite different from the data used to train this model, the video analytics accuracy at this specific site isn't great. People are not being accurately recognized and tracked, and defects are being missed. Now let's use NVIDIA Tau to solve for this. With this simple UI, we retrain and adapt our pre-trained models with labeled data from the specific environment we're deploying in. We select our datasets. Each is a few hundred images as opposed to millions of labeled images required if we were to train this from scratch. With NVIDIA Tau, we go from 65% to over 90% accuracy. And through pruning and quantization, compute complexity is reduced by 2x with no reduction in accuracy, and real-time performance is maintained. In this example, the result is 3 models specifically trained for our factory, all in just minutes. With one click, we update and deploy these optimized models onto NVIDIA certified servers with Fleet Command, seamlessly and securely from the cloud. From secure boot to our confidential AI enclave in GPUs, application data and critical intellectual property remain safe. AI accuracy, system performance, and health can be monitored remotely. This establishes a feedback loop for continuous application enhancements. The factory now has an end-to-end framework to adapt to changing conditions, often and easily. We make it easy to adapt and optimize NGC pre-trained models with NVIDIA Tau and deploy and orchestrate applications with Fleet Command.
We have all kinds of computer vision, speech, language, and robotics models, and more coming all the time. Some are the works of our genetics and medical imaging team. For example, this model that predicts supplemental oxygen needs from X-ray and electronic health records. This is a collaboration of 20 hospitals across 8 countries and 5 continents for COVID-19. Federated learning and NVIDIA Tau was essential to make this possible. The world needs a state-of-the-art conversational AI that can be customized and processed anywhere. Today, we're announcing the availability of NVIDIA Jarvis, a state-of-the-art deep learning AI for speech recognition, language understanding, translations, and speech. End-to-end GPU accelerated, Jarvis interacts in about 100 milliseconds, listening, understanding, and responding faster than the blink of a human eye. We trained Jarvis for several million GPU hours on over 1 billion pages of text and 60,000 hours of speech in different languages, accents, environments, and lingos. Out of the box, Jarvis achieves a world-class 90% recognition accuracy. You can get even better for your application by refining with your own data using NVIDIA Tau. Jarvis supports 5 languages today: English, Japanese, Spanish, German, French, and Russian. Jarvis does excellent translation. In the bilingual evaluation understudy benchmark, Jarvis scores 40 points for English to Japanese and 50 points for English to Spanish. 40 is high quality and state-of-the-art. 50 is considered fluent translation. Jarvis can be customized for domain jargon. We've trained Jarvis for technical and healthcare scenarios. It's easy with Tau. And Jarvis now speaks with expression and emotion that you can control. No more mechanical talk. And lastly, this is a big one. Jarvis can be deployed in the cloud, on EGX in your data center, at the edge in a shop, warehouse, or factory, running on EGX Aerial, or inside a delivery robot running on a Jetson computer. Jarvis Early Access program began last May, and our conversational AI software has been downloaded 45,000 times. Among early users is T-Mobile, the US telecom giant. They're using Jarvis to offer exceptional customer service that demands high quality and low latency needed in real-time speech recognition. We're announcing a partnership with Mozilla Common Voice, one of the world's largest multi-language voice datasets, and it's openly available to all. NVIDIA will use our DGXs to process and train Jarvis, with the dataset of 150,000 speakers in 65 languages, and offer Jarvis back to the community for free. So go to Mozilla Common Voice and make some recordings. Let's make universal translation possible and help people around the world understand each other. Now let me show you Jarvis. The first part of Jarvis is speech recognition. Jarvis is over 90% accurate out of the box. That's world class. And you can still use Tau to make it even better for your application, like customizing for healthcare jargon. Chest X-ray shows left retrocardiac opacity, and this may be due to atelectasis, aspiration, or early pneumonia. I have no idea what I said, but Jarvis recognized it perfectly. Jarvis translation now supports 5 languages. Let's do Japanese. Excuse me, I'm looking for the famous Jungara ramen shop. It should be nearby, but I don't see it on my map. Can you show me the way? I'm very hungry. That's great. Excellent accuracy, I think. Instantaneous response. You can do German, French, and Russian with more languages on the way. Jarvis also speaks with feelings. Let's try this. The more you buy, the more you save.
The more you buy, the more you save.
I think we're going to need more enthusiasm.
The more you buy, the more you save.
NVIDIA Jarvis, state-of-the-art deep learning conversational AI, interactive response, 5 languages, customized with Tau, and deploy from cloud to edge to autonomous systems. Recommender systems are the most important machine learning pipeline in the world today. It is the engine for search, ads, online shopping, music, books, movies, user-generated content, news. Recommender systems predict your needs and preferences from past interactions with you, your explicit preferences, and learned preferences using methods called collaborative and content filtering. Trillions of items to be recommended to billions of people. The problem space is quite large. We would like to productize a state-of-the-art recommender system so that all companies can benefit from the transformative capabilities of this AI. We built an open source recommender system framework called Merlin, which simplifies an end-to-end workflow from ETL to training to validation to inference. It is architected to scale as your dataset grows. And if you already have a ton of data, it is the fastest recommender system ever built. In our benchmarks, we achieve speedups of 10 to 50x for ETL, 2 to 10x for training, and 3 to 100 times for inference depending on the exact setup. Merlin is now available on NGC. Our vision for Maxine is to eventually be your avatar in virtual worlds created in Omniverse, to enable virtual presence. The technologies of virtual presence can benefit video conferencing today. Alex is going to tell you all about it.
Hi everyone, I'm Alex and I'm the product manager for NVIDIA Maxine. These days we're spending so much time doing video conferencing. Don't you want a much better video communication experience? Today I'm so thrilled to share with you NVIDIA Maxine, a suite of AI technologies that can improve the video conferencing experiencing for everyone. When combined with NVIDIA Jarvis, Maxine offers the most accurate speech-to-text. See, it's now transcribing everything I'm saying, all in real time. And in addition, with the help of Jarvis, Maxine can also translate what I'm saying into multiple languages. That makes international meetings so much easier. Another great feature I'd love to share with you is Maxine's eye contact feature. Oftentimes when I'm presenting, I'm not looking at the camera. When I turn on Maxine's eye contact feature, it corrects the position of my eyes so that I'm looking back into the camera again. Now I can make eye contact with everyone else. The meeting experience just gets so much more engaging. Last but definitely not least, Maxine can even improve the video quality when bandwidth isn't sufficient. Now let's take a look at my video quality when bandwidth drops to as low as 50 kilobits per second. Definitely not great. Maxine's AI face codec can improve the quality of my video even when bandwidth is as low as 50 kilobits per second. The most powerful part of Maxine is that all of these amazing AI features can run simultaneously together and all in real time. Or you can just pick and choose a few. It's just that flexible. Now before I go, let me turn off all Maxine features so you can see what I looked like without Maxine's help. Not ideal. Now let's turn back on all the Maxine features. See, that's so much better, thanks to NVIDIA Maxine.
NGC has pre-trained models. Tau lets you fine-tune and adapt models to your applications. Fleet Command deploys and orchestrates your models. The final piece is the inference server, to infer insight from the continuous streams of data coming into your EGX servers or your cloud instance. NVIDIA Triton is our inference server. Triton is a model scheduling and dispatch engine that can handle just about anything you throw at it. Any AI model that runs on cuDNN. So basically every AI model. From any framework, TensorFlow, PyTorch, Onyx, OpenVINO, TensorRT, or custom C++ Python backends. Triton schedules on the multiple generations of NVIDIA GPUs and x86 CPUs. Triton maximizes the CPU and GPU utilization. Triton scales with Kubernetes and handles live updates. Triton is fantastic for everything from image to speech recognition, from recommenders to language understanding. But let me show you something really hard: generating biomolecules for drug discovery. In drug discovery, it all comes down to finding the right molecule, the right shape, the right interactions with a protein, the right pharmacokinetic properties. Working with scientists from AstraZeneca, NVIDIA researchers trained a language model to understand smiles, the language of chemical structures. We developed the model with Megatron and trained it on a superpod, then created a generative model that reads the structure of successful chemical drug compounds to then generate potentially effective novel compounds. Now we can use AI to generate candidate compounds that can then be further refined with physics-based simulations, like docking or Schrödinger's FEP+. Generating with a CPU is slow. It takes almost 8 seconds to generate one molecule. On a single A100 with Triton, it takes about 0.3 seconds, 32 times faster. Using Triton Inference Server, we can scale this up to a superpod and generate thousands of molecules per second. AI and simulation is going to revolutionize drug discovery. We provide these AI capabilities to our ecosystem of millions of developers around the world. Thousands of companies are building their most important services on NVIDIA AI. Best Buy is using Morpheus as the foundation of AI-based anomaly detection in their network. GE Healthcare has built an echocardiogram that uses TensorRT to quickly identify different views of the wall motion of the heart and select the best ones for analysis. Spotify has over 4 billion playlists. They're using Rapids to analyze models more efficiently, which lets them refresh personalized playlists more often. This keeps their content fresh with the latest trends. WeChat is using TensorRT to achieve 8 millisecond latency, even when using the state-of-the-art natural language understanding models like BERT. This gives them more accuracy and relevant results when maintaining real-time response. It's great to see NVIDIA AI used to build these amazing AI services. NVIDIA AI on EGX with Aerial 5G, the AI computing platform for the enterprise and edge, the next wave of AI. Drive AV is our AV platform and service. AV is the most intense machine learning and robotics challenge, one of the hardest but also the greatest impact. We're building an AV platform end-to-end, from the AV chips and computers, sensor architecture, data processing, mapping, developing the driving software, creating the simulator and digital twin, fleet command operations, to road testing. All of it to the highest functional safety and cybersecurity standards. None of these things are openly available, so we build them. We build it in modules, so our customers and partners in the $10 trillion transportation industry can leverage the parts they need. Meanwhile, we build our end-to-end AV service in partnership with Mercedes. AV computing demand is skyrocketing. Orin is a giant leap over Xavier. The more developers learn about AV, the more advanced the algorithms become, and the greater the computing demand. More computation capacity gives teams faster iteration and speed to market, leading some to call TOPS the new horsepower. And many are realizing that the reserved computing capacity today is an opportunity to offer new services tomorrow. NVIDIA Drive is an open programmable platform that AI engineers all over the world are familiar with. New AI technology is being invented on NVIDIA AI constantly. These inventions will be tomorrow's new services. Orin is an amazing AV computer. Today, we're announcing that Orin was also designed to be the central computer of the car. Orin will process in one central computer the cluster, infotainment, passenger interaction AI, and very importantly, the confidence view, or the perception world model. The confidence view is what the car actually perceives around it, and construct it into a 3D surround model. This is what's in the mind of the autopilot AI. It is important that the car shows us that its surround perception is accurate so that we have confidence in its driving. In time, rear-view mirrors will be replaced by surround 3D perception. The future is one central computer, 4 domains, virtualized and isolated, architected for functional safety and security, software-defined and upgradable for the life of the car, and super smart AI and beautiful graphics. Many car companies have already adopted Orin, and so it would help them tremendously to also leverage our full AV development platform. Today, we're announcing NVIDIA's 8th generation Hyperion car platform, including reference sensors, AV and central computers, the 3D ground truth data recorder, networking, and all of the essential software. Hyperion 8 is compatible with the NVIDIA Drive AV stack, so easy to adopt and integrate elements of our stack. Hyperion 8 is a fully functional, going to production, open AV platform for the multi-trillion-dollar transportation ecosystem. Orin will be in production in 2022. Meanwhile, our next generation is already in full gear and will be yet another giant leap. Today, we're announcing NVIDIA Drive Atlan. Drive Atlan will be 1,000 TOPS on one chip, more than the total compute in most level 5 robotaxis today. To achieve higher autonomy in more conditions, sensor resolutions will continue to increase. There will be more of them. AI models will get more sophisticated. There will be more redundancy and safety functionality. We're going to need all of the computing we can get. Atlan is a technical marvel, fusing all of NVIDIA's technologies in AI, auto, robotics, safety, and Bluefield secure data center technologies. AV and software must be planned as multi-generational investments. The software you invested billions in today must carry over to the entire fleet and to future generations. The Drive Atlan, the next level, one architecture. The car industry has become a technology industry. Future cars are going to be completely programmable computers, and business models are going to be software driven. Car companies will offer software services for the life of the car. The new tech mindset sees the car not just as a product to sell, but as an install base of tens or hundreds of millions to build upon, creating billions in services opportunities. The world's big brands have giant opportunities. Step one was going electric. Now the big brands are making their new fleets autonomous and programmable. Orin will be powering many next generation EVs. And with Mercedes, we're building the end-to-end system. The world moves 10 trillion miles a year. If only a fraction of these miles were served by robotaxis, the opportunity is giant. We expect robotaxis to start ramping in the next couple of years. These services will also be platforms for all kinds of new services to be built upon, like last mile delivery. The internet moves electrons. Trucks move atoms. The rise of e-commerce is putting intense pressure on the system. One click, and a new TV shows up at your house. Another click, and a cheeseburger shows up. This trend will only go up. The US will be short by 100,000 truckers by 2023. The EU is short 150,000 truckers already. China is short 4 million drivers. So ideas like driverless trucks from hub to hub, or driverless trucks inside a port or warehouse campus are excellent near-term ways to augment with automation. We started my talk with Omniverse. We'll close with Omniverse. You could see how important it is to our work, to robotics, to anyone building AIs that interact with the physical world, to have a physically based simulator or digital twin. In the case of Isaac, the digital twin is the factory in Omniverse. In the case of Drive, the digital twin is the collective memories of the fleet captured in Omniverse. The Drive digital twin is used throughout the development. It's used for HD map reconstruction, synthetic data generation so we can bootstrap training new models, new scenario simulations, hardware-in-the-loop simulations, release validation, for replaying unfamiliar scenarios experienced by a car, or a teleoperator uplinking into a car to remotely pilot. The Drive digital twin in Omniverse is a virtual world that every car in the fleet is connected to. Today, we're announcing that DriveSim, the engine of Drive digital twin, will be available for the community this summer. Let me show you what Drive AV and DriveSim can do. This is a mountain of technology. Enjoy. What a GTC. It's incredible to think how much was done in this last year. I spoke about several things. NVIDIA is a full stack computing platform. We're building virtual worlds with NVIDIA Omniverse, a miraculous platform that will help build the next wave of AI for robotics and self-driving cars. We announced new DGX systems and new software, Megatron for giant transformers, Clara for drug discovery, and cuQuantum for quantum computing. NVIDIA is now a 3-chip company with the addition of Grace CPU, designed for a specialized segment of computing focused on giant scale AI and HPC. And for data center infrastructure processing, we announced Bluefield 3 and Doka 1. NVIDIA is expanding the reach of AI. We announced an important new platform, NVIDIA EGX with Aerial 5G, to make AI accessible to all companies and industries. We're joined by the leaders of IT, VMware, computer makers, infrastructure software, storage, and security providers. And to lower the bar to the highest levels of AI, we offer pre-trained models like Jarvis Conversational AI, Merlin Recommender System, Maxine Virtual Conferencing, and Morpheus AI Security. All of it is optimized on NVIDIA AI Enterprise. And with new tools like NVIDIA Tau, Fleet Command, and Triton, it is easy for you to customize and deploy on EGX. And Drive, our end-to-end platform for the $10 trillion transportation industry, which is becoming one of the world's largest technology industries. From Orin and Atlan, the first 1,000 TOPS SoC, to Hyperion 8, a fully operational reference AV car platform, to DriveSim, to Drive AV, we're working with the industry at every layer. 20 years ago, all of this was science fiction. 10 years ago, it was a dream. Today, we're living it. I want to thank all of you, developers and partners, and a very special thanks to all the NVIDIA employees. Our purpose is to advance our craft so that you, the Da Vinci's of our time, can advance yours. Ultimately, NVIDIA is an instrument for you to do your life's work. Have a great GTC.